Welcome everyone to a session on UNIX programming. This will be the continuation of module 4, chapter of process control, and here we will be looking into the concept topics of process accounting, user identification and process times. So we'll start with the process accounting. So what does process accounting mean? See, as the name suggests, it has accounting in it, right? And accounting means recording some information, and process accounting in the sense we are recording the information belonging to processes. Okay, and these are the important points what we have to know with respect to process accounting. See, and the first question is, which module performs this accounting or maintains accounting? So that is done by the kernel. The kernel writes an accounting record each time a process terminates. So this is what we have to remember. So accounting data is recorded when the process gets terminated, and these accounting records are a small amount of binary data with some of the information such as name of the command, the amount of CPU time used, the user ID and the group ID to which the process belongs to, the starting time and few other information. Okay, so when the accounting is done, it is the super user, when the super user executes ACCT system call with the path name argument to enable accounting. Okay, so a super user executes the system call ACCT with the path name argument, then the overall process of accounting will be enabled. Okay, and the accounting record is typically written to a specified file which is mentioned here in the path name. Okay, so the accounting information are usually stored in this file present in this path name, and the accounting is turned off again by a super user by executing the same system call ACCT but this time without any arguments. Okay, so this is how we can disable the accounting process or recording the accounting process. And the data required for accounting record such as CPU time and the number of characters transferred is kept by the kernel in a special table called as process table. Okay, and it is initialized whenever a process is created, normally during a fork system call. Okay, and each accounting record is written when the process terminates. This is already mentioned, right? Okay, so which means the order of the records in which the accounting file corresponds to the termination order of the processes. So it is not the accounting record is maintained in the order in which the process terminates rather than the time at which the process begins its execution. And the accounting record corresponds to the processes, not programs, and a new record is initialized by the kernel after a fork system call and not when the program is executed. Okay, so these are some of the points what we need to know with respect to process accounting. The accounting details are maintained by using the data type ACCT, which is a structure, and these are the heterogeneous values of the process that got recorded, right? So this contains the recording information. Let us see each one of these. First one being the flag. Okay, so this will be set to one of the flag values which we will be looking in the upcoming slide. Okay, then come the termination status of the process, how the process got terminated. UID, the real user ID of the process to which it belongs to, the real group ID to which the process belongs to, the controlling terminal of the process, the starting calendar time, okay, and the user CPU time, user system time, system CPU time, elapsed time. So all this information regarding time we will be looking in the very soon in the upcoming slides. Okay, so this will be explained in detail in the upcoming slide. The average memory usage by the process. This contains the amount of bytes that has been transferred by the read and write system call that is used by the process. Then the blocks read or written by the process, and this contains the name of the command that got executed. Okay, and this 8 value is for the Solaris, which is one of the flavors of Unix, and it has different values. See, this is for different operating systems of Unix. Okay, and 17 is for the Linux. So if you see 8 here, then we are referring to the Solaris version of Unix. Okay, and so this structure is used for accounting records, is defined in a header file called as acc.h. Okay, so it is present under this. Now let us look into the various flag values as mentioned. Okay, so these are the possible flag values for the that is maintained in the record. A fork, which means this is set when the process is the result of fork system call, but it never called exec system call. Okay, and ASU, when a process used super user privileges, and when a process used a compatibility board, a compat is set, and process dumped core, this this flag will be set, and AX signal is set when the process was killed by a signal. Okay, and A expand is used to set when the expanded accounting entry. Now let us consider the programming example to understand process accounting better. So this program is used to generate the data, accounting data, by forking a child process multiple times. To be precise, 4 child process will be created in this particular program. Okay, so let us see how this program work. Here the parent process, it will call, this is for the parent process, it calls a fork system call, and yeah, if it is less than 0, obviously there is a fork error, but if it is not, then the condition comes here. We'll check for the condition which PID is not equal to 0. See, we all know that when a fork system call is called, 2 copy of this program will be created, one for the child process and one for the parent process, and parent process will receive the process ID of the child process. So this PID value will be the parent ID of the child that has been created. That's for the parent, that is what is returned. And if the fork is successful, then the child will return the value 0, right? So if I give this condition not equal to 0, then obviously I am referring to the parent process, right? And what if this condition is true, then no operation is done, that is the parent process is made to sleep for 2 units of time. This is what is passed, and it will be exited with the exit status as 2, right? So this is for the parent process, right? Okay, now coming to this part, when will the control come here? When this condition is not true, control will come here, right? So obviously this is for the first child, and in the first child, yes, this is what it is meant, and in the first child again it calls the fork system call. So the first child again forks another child process, right? So to the next child process, this will become the parent, right? Okay, again we'll check for the same condition. If it is not less than 0, then, and if the PID is not equal to 0, so this is for the first child, which now is the parent, right? Parent of the second child. So what is done? It is made to sleep for 4 units of time, then it is aborted. This particular process is aborted. So the first child is aborted after made to sleep for 4 seconds, or 4, not second, 4 unit of time, right? Okay, so it will be terminated with the core dump. Okay, yeah, so if this condition is not true, then again will come here, right? So this is for the child process, and child process again will call a fork system call. Okay, and PID is not equal to 0. Yes, this second child is now, the condition is now that this is the parent, isn't it? Okay, so if this is true, then see, execl system call will be used system function will be called, and uh, it is executed. This path is given right in the exec. So this dd basically performs some uh, copy operation which we are not bothered about, right? So we are not bothering about what the function of this dd is. We are making use of this program only to generate the accounting record. Okay, yes. So this process, that is a child process 2, is not exited, but it calls the exit system call, right? Okay, if this is not the condition, the control comes here again. Yes, so this is for the child, third child. Again it will call a fork system call, and this condition is for the parent, which is nothing but the third child now, right? So this is the parent, and it will be made we will call the sleep system call for 8 unit of time, and then it will be exited with the exit status 0, which is nothing but the normal exit, right? And yes, this is the final condition here, which is for the child of this child of this third child process, which is currently the parent here, right? Okay, so what do we do for the fourth child? We simply make it sleep for 6 units of time, then it will be killed, right, using the kill system call. Okay, yes. So this is a small program where we create 4 child process, and each of these are exited in a different manner, right? Now let us examine this and try to understand how the child process are created. So this structure, this is the process structure for the program what we just saw, right? So initially the parent process, which forks a first child process, right, and this will be made to sleep for 2 unit of time, then will be exited with the exit status 2, and the first child again will fork another child process, and it is aborted using the abort system call, and the time passed here is 4, right? And if you observe, the second child is not exited, but it will call the execl system call, right, to this one. Okay, this is the path name that is specified, and it also forks another child process, and which is again um, made to sleep for 8 unit of time, and we have a normal exit, right? So this is exited normally, and again this will call a fork system call, where the last child is made to sleep for 6 units of time, and it is terminated using the kill system call, right? Okay, now by considering this particular example, this particular programming example, we shall see how the accounting records are written in what order. Okay, okay, now assume that we are in a normal user mode, that is not a super user. Okay, assume that I am executing this particular program and I am not the super user. So to enable accounting, I need to have the super user privileges, which is already mentioned in the previous slides, right? Okay, so the first thing, if I want to perform recording, is that I need to gain the super user privilege. Okay, so this is done by using the super su command. So new super user shell will be created, isn't it? Okay, so new super user shell will be created. Okay, now after gaining the super user privileges, what do I need to do? I need to execute this command ACCT, and this can be executed only by the super user with some here parameter, whatever the see, I have to pass the parameter to enable the accounting, isn't it? So this is the command that I need to execute to enable the recording. Okay, so this is done, this command will be executed. Okay, okay, so here I will write the accounting data or accounting account records in order. Okay, yeah, okay. See, as soon as I execute this ACCT command, the accounting of the processes starts, right? And what can you tell me, if you make a guess, what should be the first entry in this, or in accounting, in the process accounting? What will be the entry or which process will have its entry first? Okay, that is nothing but ACCT itself, because see, when ACCTON is executed, I will enable the recording, right? And when this gets terminated, so when I say that this gets terminated, when it is successful, isn't it? So this will be the first process that gets recorded in the accounting, in the process accounting, right? So the first entry will be ACCTON itself. Okay. Okay. Now what I will do is I will exit now after executing this ACCTON. Okay. So after this is successful, it will be entered here in the record, accounting record. Now I will exit the super user. I will exit the super user. So I will terminate the super user shell. So even this shell will be terminated, isn't it? So as soon as any process is terminated, it will be recorded in the, or its record will be put in the process accounting data, isn't it? So the second one is SH itself, which is for the super user. So this will be entered next, because I will exit the shell of the super user, and it will be entered in the file. It will be entered in the file. So this will be the second entry. Okay. Okay. Now what will be the third entry? Third entry in the sense, now being in the normal user mode, I will execute this particular program. Okay, this particular program, and obviously this particular program, when I execute, 4 processes will be created, isn't it? 4 child processes will be created, and including parent, the total number of processes will be 5. 1, 2, 3, 4 and 5. Okay. Now we shall examine in what order the entry will be written. Okay. So you have to make a, you have to understand this, and let's see which one will be entered first. So the one which will be entered first will be the one that gets terminated first, right? Okay. So among this, which one is the first that gets entered? So that will nothing but the second child, because second child will perform execl and it will be executed. See, if you observe, the other process is made to sleep, isn't it, for some amount of time, and second child is not made to sleep, so immediately it will be executed and it gets terminated. So second child will be the process belonging to the second child will be the first entry in my process accounting record, isn't it? Okay. Now I have 4 more now: the parent, child, first child, third child and fourth child. So what should be the next process that gets terminated? Obviously the one with which executes first will be entered here, right? So among this, which one will be executed first? It will be the parent process, because it is having the smallest execution time. So parent will be the next entry. Okay. After this, among first, third and fourth child, it will be the first child, and next among these two, third and fourth child will be executed first or terminated first, and finally third child will be entered next. Okay. So this will be the accounting, the details of the processes that got terminated. First is ACCTON command, which was enabled, and it was the first one to get exited, right, or terminated. So this will be entered first. Then I exit the super user shell. So this will be the second one. So obviously shell is also a process, right? Then being in the user mode, the normal user mode, I will execute this particular program, and here I have 4 child and a parent process. So among this, the second child will be executed first. So its entry will be entered first in the process accounting record, then followed by a parent, first child, fourth child and third child. This is based on their termination order, right? So which can be very easily determined by with the value of the sleep here, right? Okay. So after this, what I need to do? I need to go back to the super user, right? So after executing this particular program, execute program. Okay, now I want to disable accounting. So what I have to do? Again, I have to go to the super user privileges. So again, I need to create a new super user shell, right? So this will be created, and again ACCTON command should be executed without any parameters. Okay, so if I execute this particular command without any parameters, then it will disable the recording, right? So it will disable the recording. Okay, and after disabling the recording, it will get terminated. Okay, so after it gets terminated, its value, this is also a process, it will not be entered in the recording process accounting record, because I have already disabled it, then this process got terminated, right? So it will not be entered. Now even if I exit from a super user shell, okay, if I then come back to the user mode, again even this process accounting is not done, because ACCTON command is disabled, isn't it? So this is an example of the program that performs process accounting in a certain order. Okay, so this is about process accounting. The next topic is about user identification. We know how a process can find out its effective and real user ID as well as group ID. But sometimes it is necessary to know the login name of the user who is running the program, right? And this can be obtained by using this particular function, get login function. So get login function will provides a way to fetch that login name. Okay, so it will return a pointer to the string giving the login name if everything is okay, and it will give a null on error. Okay, so this will be the value that will be returned. So this is about user identification, that is fetching the login name of the user. The last topic, we will look what exactly process times are. Okay, so basically there are we can describe 3 times what we can measure. One being wall clock time, user CPU time, and system CPU time. So what would be wall clock time? Wall clock time is nothing but the total time spent by the process in the system. That is nothing but the time difference between the time when the process gets executed and the time at which the process was started. Okay, so this is about wall clock time. And then we have user CPU time and system CPU time. So this is again the difference is whether the time spent in user space or kernel space. So that based on that we have the differences. So user CPU time is the time spent on the processor running the user's code. Okay, and the CPU time is the time spent running code in the operating system kernel on behalf of the program. Okay, so this is running the time spent in the user mode, and this is the time spent in the kernel mode. Okay, okay, and any process can call the time function to obtain these values for itself and any terminated children. So this is the function that provides this information. Okay, what it returns? It returns elapsed wall clock time in the clock ticks if everything is okay, and -1 on error. Okay, so as you can see, this TMS, it's a structure, and the function will fill in the function fills in the TMS structure pointed by the buffer, and this is the structure what we are talking about. Okay, as you can see here, we have user CPU time, system CPU time, user CPU time for the terminated children, and system CPU time for the terminated children. Okay, so this is about the process times. Okay, and by using the times function, we can obtain the elapsed clock time in clock ticks. So this is about the first chapter in module 4, that is process control. So we're done with the process control. Then in the next session we will continue with the new chapter. I'll see you all in the next one.